Hello everyone. In this video, I will talk about the last part of the sample problem. I will talk about how to calculate the fine aggregate content, how to do moisture correction, and then do a brief summary about the sample problem. So in the previous class, I have talked about how to calculate the volume of fine aggregate. Basically, we need to use this equation, and we need to first calculate the volume of water, the volume of cement, the volume of air, and the volume of coarse aggregate. So let's see how to calculate the volume of water. So this is the ninth step to calculate fine aggregate content. We need to first calculate the volume of water. So the volume of water is the weight of water per cubic yard of concrete divided by the unit weight of water at 4 degrees Celsius. So in the previous step, we calculate the water content. The weight of water is 250 pounds per cubic yard of concrete. So this value divided by the unit weight of water, which is 62 point, let me check. So this is 62.4, which is the unit weight of water at 4 degrees Celsius. So then we can get the volume of water, which is 4.006 cubic foot per cubic yard of concrete. And then we need to calculate the volume of cement. So cement volume. So the volume of cement is the weight of cement per cubic yard of concrete, which is 564 divided by the unit weight of cement. So we know the specific gravity of cement is 3.15. So the unit weight should be 3.15 times 62.4. So if you calculate the volume of cement should be 2.869 cubic foot per cubic yard of concrete. And then we need to calculate the volume of air content. So air volume, we know that the air content is 7% of the volume, the total volume. So the total volume is 27. So the volume of air, if you calculate this value, it's 1.89 cubic foot of air per cubic yard of concrete. And then we need to calculate coarse aggregate volume. In the previous step, we know we need 1160, no, not this value, it's 1956 pound of coarse aggregate per cubic yard of concrete. So this divided by the unit weight of coarse aggregate. So in this question, we know the specific gravity of coarse aggregate is 2.621. So it's 2.621 times the unit weight of water, 62.4. So this will be the volume of coarse aggregate. If you calculate this value, it's 11.96 cubic foot of coarse aggregate per cubic yard of concrete. And then finally, the fine aggregate volume should be 27 minus 4.006 minus 2.869 minus 1.89 minus 11.96. So this should be 7. This is about 14. So this should be approximately equal to 6. Yeah, so it's 6.275 cubic foot per cubic yard of concrete. So that's the volume of fine aggregate per cubic yard of concrete. So if you want to calculate the weight, it should be the volume, which is 6.275 times the unit weight of fine aggregate, which is the specific gravity of fine aggregate, which is 2.572 times the unit weight of water at 4 degrees Celsius. So this gives you the weight of fine aggregate per cubic yard of concrete, which is 1007 pound per cubic yard. That's the weight of fine aggregate. However, when we calculate the fine aggregate content and the coarse aggregate content, we didn't consider the moisture, so we need to do the moisture correction. So this is the last step, do a moisture correction. So in the previous calculation, we assumed both coarse and fine aggregates are dry, but actually, according to the problem, they are not actually dry. So coarse aggregate have moisture content 1.5, and the fine aggregate have moisture content 4. So we need to calculate the actual weight of coarse and fine aggregate. So the coarse aggregate, the dry weight, is 1956. So if you include the moisture content, you need to have 1956 times 1 plus 0.015. So if you calculate this value, it's 1985 pound of coarse aggregate per cubic yard of concrete. So that's the moist coarse aggregate weight. So similarly, we can calculate the weight for moist fine aggregate. So the dry weight is 1007 times 1 plus 0.04. So this value should be 1047 pound of moist fine aggregate per cubic yard of concrete. Okay, so then we need to calculate the actual amount of water we need to use. If we don't consider the moisture content, in the previous step, we calculated that the amount of water we need is 250 pounds per cubic yard of concrete. So we need to calculate the actual amount. So for the coarse aggregate, we know that the absorption value is 2.4 and the moisture content is 1.5, so which means it needs more water to reach the SSD condition. So we need to calculate this amount of water. So it's 2.4 minus 1.5 times the dry weight of the coarse aggregate. So it's 1956 times this amount. This should be 100%. And if you calculate this value, it's about 17.604 pound per cubic yard of concrete. And this is the water needed by the coarse aggregate in order to achieve the SSD condition. So let's see the fine aggregate. The absorption value is 0.8 and the moisture content is 4. So it has more water than the SSD condition. So we can calculate this amount of the excessive water. So the dry weight of fine aggregate is 1007 times the, let me see the difference between the absorption and moisture content. 4 minus 0.8. This is 100%. And if you calculate this value, it's 32.224 pound of fine aggregate, of moist fine aggregate per cubic yard of concrete. Okay, so let's calculate the actual amount of water we need. So it's 250 plus 17.604 and minus 32.224, because this is the excessive amount of water and this is the water needed by the coarse aggregate in order to achieve the SSD condition. So the actual amount of water should be 235 pound per cubic yard of concrete. Okay, so then we finished this problem. So let me do a brief summary about the ingredients. So we need water, which is 235 pound for every cubic yard of concrete, and the cement is 564 pound, and the coarse aggregate is 1985 pound, and the fine aggregate is 1047 pound. And finally, we also need admixture, which is iron trainer for this case. So we need 3.9 fluid ounce per cubic yard of concrete. So all of them is per cubic yard of concrete.